Okay, chapter 10.8, vectors. This is page 6. So continuing on what we talked about on page 5, we're going to talk about, as we write vectors in terms of their unit components, I and j, how we perform operations. And it's kind of nice when we look at them this way, because then we can perform operations algebraically the way that we're comfortable with. Okay, so here we're back to a vector where they're giving us the initial point and the terminal point. So the first thing I want to do is definitely find that position vector. So I've got -6, the terminal point, -2, which is our initial point, and 6 minus -6 for that y component. So I get a position vector of -8, +12, and I'm not sure that I remember why I put the graph there. -8, 12. Graph's not even big enough. Anyway, we want the vector in terms of I and j. So just a reminder, this vector v could be written as -8, 0 plus 0, 12. Right? If I added those together, I add my x components, I get -8 plus 0, which is -8. I get 0 plus 12, which is 12. And so I'm writing this in terms of its component pieces, which means that's -8 times the vector 1, 0, plus 12 times the vector 0, 1. The vector 1, 0 is I. The vector 0, 1 is j. And so there is our vector written in terms of I and j. And we're just going to let the graph go for now. If I remember as we move down the page why I stuck that graph in there, we'll come back to it. But yeah, we're good. At this point, most students like working with the vectors algebraically rather than geometrically, because it's pretty straightforward when we've got them written in terms of its, in terms of I and j. Okay. So when we're going to add and subtract, it's going to work the way that you think it does. If I have some a times my I, my 1, 0, and I have some c times my I, my 1, 0, I am just going to combine how many we have all together. Okay. So this part right here basically just says we want to combine like terms. That's it, right? And so if I want the sum of v1 plus v2, I'm going to line them up vertically. I got 4i minus 6j and 3i plus 5j. I'm just going to add straight down. I get 7i minus 1j. Okay. Yeah, and that's my sum. If I were to write this horizontally, v sub 1 plus v sub 2, I get 4i minus 6j plus 3i plus 5j. Again, we are going to combine like terms. And if we want it to match the formula that we have above, this is all the stuff you've gotten really used to doing in your head. And so a lot of times we don't write it out anymore. So there's the sum of v sub 1 and v sub 2, 7i minus 1j. Okay. That scalar multiplication, you guys, that's going to work the way you think it does as well. So let's just use v. If v is ai plus bj, and we want some scalar, let's call it S times V. It's going to be S times AI plus S times BJ. So that scalar multiplier is going to multiply the multiplier on our unit vector. Got to be a better way to say that. So if we want 1/2 v sub 1, it's a 1. That's 1/2. My v sub 1 was what? 4i minus 6j? One half of 4 is 2i. 1/2 of 6 is 3 times j. One more time, 8 times v sub 2 is 8 times, what do we have, 3i plus 5j. 8 times 3 is 24. 8 times 5 is 40. So written this way, as a linear combination of the unit vectors, we work with it algebraically the way we're used to doing algebra.